Okay, hey guys, this is the last video. This is problem 3. And for this one, this problem looks complicated, and it is pretty complicated. It's more complicated than anything I think you would see on the exam. Particularly, you might see distributed loads, you might see point loads, but what you probably won't see is a distributed load that's only applied on a portion of the beam. But we can still solve this problem, and I was going through this, and it's actually not as difficult as I had originally thought it would be. You just need to be careful with the shapes that you end up making. Okay, so what I'm going to try and do, I'm going to show you your P systems, and I'm going to show you how to analyze this force in particular. So and once you have that, I think that's the most complicated portion. The rest of this should be fairly straightforward. Let's get started. I think your original problem is like this. This is 2 EI. These two are both EI. This is your original problem. I'm going to say, let's turn this pin into a roller. Then we would have some extra force, let's call that dx or r. I want to split this up into 4 systems. And you're like, 4 systems? No, but it'll actually be easier if we do it this way. I'm going to analyze this one. I'm going to analyze, let's do blue. Analyze this one. I'm going to analyze this one. And then I'm going to analyze this one. I also need a Q system. My Q system will look very similar to this one. It'll just be of 1, value of 1 there. Okay, now I already said I'm just going to focus on this one. This is how you would break up your system. So this is P1, P2, P3. Let's say this is R. This is your Q system. I would analyze, so do P1 times Q plus P2 times Q plus P3 times Q plus R times Q equals 0. And yes, I'm using virtual work for this one. I do not think moment area is a very good idea for this problem. Professor might think otherwise. I'm not entirely sure. I won't know for sure until I see his solution. But I'm pretty sure virtual work will be easier. All right, for the P1 system, let me draw the Q system first. Let's get the moment diagram for that out of the way. With a unit load of 1 out here, and I'm going to make positive outside, which I think is opposite of what the professor does, but as you should be aware by now in this course, you can use any sign convention you'd like. You just need to properly define it. So this will be 1. This will be times L. 1 times L is just going to be L up here. The moment diagram is continuous all the way across the top. It's also L. And then we go back down to 0 here. So this is also L. So it's L all the way around. It's triangle, rectangle, triangle. Top part is all L. Let's look at our P1 system. Our P1 system was this. If we find the reactions first, we'll find that the reaction this way is P on 2. The reaction this way is 3P on 8. The reaction downwards here is 3P on 8. My moment diagram for this is going to look something like, this is going to be parabolic, this part. It's going to be linear here. It will be triangular going down like this. And then if I look out here, I'll have 0 moment in this arm. This value out here, and I'll let you figure out how to get these values. I think that's probably the most important part of this of this problem, but not this problem of this course, figure out how to get moment values, but this is 3p on 8, 3pl on 8, and value here. Now let's look at that portion. That portion, if I draw this out horizontally, is equal to something like this. I already said that this value out here was 3pl on 8. The height here is p on 2 times l on 2. So this is 2pl on 8. It's pl on 4, but I want to have everything in the same base so it's easier to work with. My Q system, that is my P system, right? My Q system is just this triangle. This is L, this is L, this is L up here as well. I need to analyze this triangle times this triangle, and then I need to do something weird here. This is kind of an oddly shaped parabola. What I'm going to do is I'm going to take the whole rectangle, a rectangle that covers the entire part, and I'm going to subtract off this portion. And what do I mean by that? Let's look at let's do the Q systems first. I'm going to call, sorry, let's do this piecemeal. Okay, so I'm going to start off with this triangle times a triangle. Let's call that delta P1 with a little circled 1 up here to show that it's the first part, and I'm going to put 1 in here. Delta P1 is going to be equal to, I believe this is 1/3 times 2pl on 8 times, and this height here is going to be L on 2. This is L on 2. Half the base is going to give me half the height by similar triangles. Total length is L on 2. I should get that this is equal to PL on 48. And I need to add in my EI here. So that's the first part. Now let's do the big rectangle of 3pl on 8 times the trapezoid. Can you see that in here? Yes. Okay. This is going to be L. This is going to be L on 2. If I go back to my tables, this is my Q system, right? My Q system is a trapezoid. A rectangle times a trapezoid. It's going to be the average of the trapezoid bases times the height of the rectangle times the length of both shapes. So and let's call that 2. So delta P12 is equal to 1/2 L on 2 plus L times 3pl on 8 times L on 2. Let me just double check that I have the right values in there. This all looks good. This is going to become 3L on 2. If I multiply this all out, I'm going to get 9pl cubed on 64 EI. Okay, now I said that this was too much. I'm going to subtract off this top portion here. And if I do that, then I should get that. I'm going to use, I'll stick with black. So delta P13 is going to be equal to this parabola times this trapezoid. Oh, that's what I wanted to do. I wanted to redraw my shape. Okay, so it's going to be this parabola times this shape. The height of this parabola is PL on 8. The height of the parabola is 3PL on 8 minus 2PL on 8. So this is just PL on 8. The heights of the trapezoid do not change. So this is going to be L on 2 and L. My formula for this one is going to end up being, I need to use trapezoid times parabola. M2 in this formula is the side with the base on it. Is the side that corresponds to the base of the parabola. So if I look here, this parabola has a base on the left, on the right hand side. My parabola has the base on the left hand side. M2 corresponds to the part that has the base. Therefore, my M2 is going to be here. This is my M2. This is my M1. In other words, when I look at my equation, my delta equals 1 on 12, M1 plus 3 M2, M3L. This 3 corresponds to the side that has the base. So the base is on this side here. This will be the one that has the 3. And if I do that, I'm going to get delta M1 times L plus 3L on 2. Let me just double check this here. Did I mess this up again? Okay, I'm going to make a correction later on in this just to make sure, but 3L on 2. This is going to be times PL on 8. So we times L on 2. And this should give me, let me just double check my numbers here really quick. So I'm getting 1 plus 3 on 2. Sorry, that should be divided by 112. Divided by 12, divided by 8, divided by 2. And this is going to give me 5 on 384 EI. Okay, so that is all good. Now let's look at, so that was covering the entire left-hand side. We also have this triangle times a rectangle. That let's call that delta P14 is going to be equal to 1/2 times L times 3PL on 8. And this will be equal, sorry, I'm going to also multiply this by L. 3PL on 8. This will be equal to 3PL cubed on 16 EI. Okay, so that part is all good. Now let me just double check my numbers really quickly from something else here. You know what, I'm going to have to make a second part to this video just because I'm missing my notes from something. But yeah, this is the general procedure. I'm just going to check my numbers really quick and then I'll update everything on the second part of this video.